Hello everyone, welcome back to my YouTube channel. Hope all are doing well. And this is a video on the topic digital counters with Q implementation. This is our project that we have done in our college, and in this video we will explain how it is done use, using CAN queues and also a process management, that is ESP32. Yeah, let's get into the video. Firstly, I would like to give an overview of our project. This project demonstrates a digital counters with a queue implementation designed to simulate a queue management system using an ESP32 microcontroller and a common cathode 7 segmented LED display. The system counts and displays numbers sequentially, representing token or queue numbers incremented via a push button interface. The counter supports continuous incrementing from 0 to 9, looping back to 0 after reaching a maximum count. Applications of this design extend to token systems and public spaces like banks, hospitals, or service counters, demonstrating a practical implementation of queue management system. This project is an excellent entry point of understanding the interface integration of microcontroller programming and hardware interfacing while providing a real world use case for embedded electronics. And it is a slide about introduction. Queue management systems are essential in environments where orderly service is required, such as banks, hospitals, and ticket counters, as we discussed before. Digital counters are a fundamental component of these systems, allowing for the sequential display of queue or token numbers. This project focuses on building a cost-effective and compact digital counter for queue management. Using an ESP32 microcontroller and a 7-segmented LED display, the system demonstrates essential embedded electronics concept, including GPIO, that is general purpose input or output, control user input handling, and a digital display management. And the next topics will be explained by our friends.
Hello everyone, this is Chaitanya KV. In this project, we aim to achieve the following objectives such as developing a digital counter which is capable of displaying numbers from 0 to 9 sequentially. The second one is implementing a push button where interface to simulate queue number propagation. And the third one is demonstrating hardware software integration with minimal components, and the fourth one is to provide a scalable framework for future enhancements like adding multiple displays or remote control functionality. And the next slide is components required for the implementation. The components we use to bring this project to life include an ESP32 microcontroller for processing and control. The next component is a 7-segmented LED display for visually displaying the numbers, and the two push buttons were for the user input and number propagation, and the supporting components like resistors and wires and a breadboard and to complete this circuit connections. This format will make it clear and engaging for your viewers. Thank you.
Circuit uses an ESP32 to control a 7-segment display and two push buttons. The display shows numbers 0 to 9 incremented or decremented using the buttons. A 220 ohm resistor limits current to the display, and each button has an internal pull-up resistor for stable input. So we don't have to connect the external 10k ohm resistor for the buttons, as the ESP32 supports internal pull-up resistors. The display is connected to 7 GPIO pins, while the buttons control increment and decrement functions. The ESP32 updates the display based on button presses. The 7-segment display is called a 7-segment display because, as you can see, there are 7 separate LEDs in the display which can light up individually based on the need. For this project, we have specifically used a common cathode display in which the cathodes of all the LEDs are connected to a single pin known as the common cathode. Each segment has its own anode connected to individual control pins. Now for the working principle. The ESP32 controls the 7-segment display by lighting up specific segments to show numbers from 0 to 9. Push buttons acts as input controls. Button 1 increments the counter by 1. Button 2 decrements the counter by 1. A queue-based mechanism stores and processes button inputs, ensuring sequential updates to the display and smooth functionality. The current counter value is displayed both on the 7-segment display and in the serial monitor for real-time monitoring. As you can see, this is the initial setup of our hardware components, and this is how the digital counter works.
When it comes to the advantages and the disadvantages of this project, the main advantages is the circuit is easy to build, understand, make it ideal for the beginners in an electronic. It has a low cost, readily available, inexpensive components like 7-segment display and the push button. When it comes to the disadvantages, these projects can only display the single digit number, restricting the practical use, requires a constant power source which could limit portability. When it comes to the application part, it is used in the place like banks, hospitals to manage the token system to ensure the customers are used in a correct order without skipping anyone. In the operating system, a counter keeps a track of tasks in the queue for the sufficient scheduling. Queues and the counter manage vehicles at the toll booths signals to reduce the congestion. Here how elements like DDCO, OS, DSA relates to this project. DDCO understand the architect of the microcontroller for input and output for the 7-segment display. When it comes to the operating system, demonstrate how microcontroller handles the hardware events efficiently. When it comes to the DSA, mapping and the array concept is used where the array store the segment pattern from 0 to 9. Thank you for watching this video. If you like this video, please do like, share and subscribe.